Download this code from codegive.com, link in the description below. OK, let's dive deep into LR0, grammar parsing, compiler design, and a practical example, all explained with a Telugu perspective. While I can't write code comments or variable names directly in Telugu, my code output will be in standard programming languages like Python. I'll explain the concepts and code using Telugu analogies and examples wherever possible to make it easier to understand. What is a compiler and why we need parsing? A compiler is like a translator that converts code written in a high-level language, like C, Java, Python, into a lower-level language, like assembly or machine code, that the computer can directly understand and execute. Imagine you have a Telugu speaker, the programmer, and a Hindi speaker, the computer. The compiler is like a Telugu-to-Hindi translator. Parsing is a crucial step in the compilation process. Think of it as the first stage of translation. It's like taking a Telugu sentence and breaking it down into its grammatical parts, subject, verb, object, etc. Parsing analyzes the syntax, grammar, of the source code to ensure it's correct and structured properly. Without proper syntax, the compiler can't understand what the code means. LR0, parsing, a bottom-up approach. LR0 is a type of bottom-up parsing. Let's break that down. Bottom-up *, imagine building a house. You start with the foundation and work your way up to the roof. Similarly, in bottom-up parsing, we start with the smallest units of the source code, like individual characters or tokens, and gradually combine them to form larger and larger grammatical structures until we reach the top-level goal, usually the entire program. Think of building puliora. You start with cooked rice, add tamarind paste, spices, and then combine to get the final puliora dish. We're building from the bottom up. *LR stands for left to right, rightmost derivation. Left to right *, the parser reads the input code from left to right, just like we read a sentence. Rightmost derivation *, the parser constructs the parse tree, the grammatical structure, using a rightmost derivation. This means the rightmost non-terminal symbol in a production rule is replaced first during the derivation process. *0 The 0 in LR0 refers to the number of look-ahead symbols the parser considers. LR0 parsers make decisions without looking ahead at the next input symbol. This makes them simpler to implement but also less powerful than LR1, SLR1, LALR1, etc., which can look at one or more symbols ahead. LR0, parsing concepts in Telugu *. Grammar, Vikaram, the rules that define the structure of our programming language. Like Telugu grammar rules that specify how words combine to form sentences. Production rule, Utpatti Niyamam, a grammar rule that defines how a non-terminal symbol can be replaced by a sequence of other symbols, terminals or non-terminals. Example, statement if condition then statement else statement. Terminal symbol, Anthemachinam, the basic building blocks of the language. Example keywords like if, else, operators like plus, equals, identifiers, numbers. Like the words in a Telugu sentence. Non-terminal symbol, Anthemacani Chinam, symbols that represent grammatical categories. Example statement, expression, condition. These are placeholders that can be replaced by other symbols according to the grammar rules. Think of the grammatical categories in a Telugu sentence. Start symbol, Paramhachinam, the non-terminal symbol that represents the entire program or the top-level grammatical structure. Item, Vastu, a production rule with a dot, dot, at some position on the right-hand side. The dot indicates how much of the rule has been seen so far. For example, A-.BC, A-B.C, and A-BC are all items for the production rule A-BC. Asterisk state, Sthiti a set of LR, 0, items. The parser moves between states as it processes the input. Asterisk goto function, goto be a function that takes a state and a symbol, terminal or non-terminal, as input and returns the next state. It determines how the parser transitions between states based on the input. Asterisk action table, Chariyalanapadika a table that specifies what action the parser should take in each state for each terminal symbol. Actions can be asterisk shift asterisk move the current input symbol onto the stack and go to a new state. Asterisk reduce asterisk replace the symbols on top of the stack, corresponding to the right-hand side of a production rule, with the non-terminal symbol on the left-hand side of the rule. Asterisk accept asterisk the parser has successfully parsed the input. Asterisk error asterisk the input is not grammatically correct. Asterisk parse stack, Analishana Stapana a stack data structure used to keep track of the symbols and states that have been processed. Steps in LR, 0, parsing asterisk. 1. Augment the grammar asterisk add a new start symbol S and a production rule S-S, where S is the original start symbol. This helps with the accept action. 2. Construct the LR, 0, automaton, finite state machine. Asterisk closure asterisk for each item, find the closure. If an item is A-alpha.b beta, where alpha and beta are sequences of symbols, and B is a non-terminal, then add all items of the form B-gamma, where gamma is the right-hand side of any production rule for B, to the closure. Repeat this process until no new items can be added. Imagine this as expanding your knowledge. If you see a word you don't know, you look up its definition and any related terms, and then look up those terms as well, until you have a full understanding. Asterisk go to asterisk for each state and each symbol, terminal or non-terminal, compute the go to, state, symbol. This involves moving the dot past the symbol and then taking the closure of the resulting item. This helps move from one state to another depending on the symbol. Asterisk repeat until no new states can be added. 3. Build the parsing table asterisk. Asterisk action table asterisk. Asterisk if goto, state, terminal, equals new underscore state, then action state, terminal equals shift new underscore state. Asterisk if item A-alpha is in state and A, equals S, then action state, terminal equals reduce A-alpha for all terminals terminal. This is where LR, 0, can have conflicts, we'll discuss that later. Asterisk if item S-S is in state, then action state, $equals accept, where $ represents the end of the input. Asterisk go to table asterisk if go to, state, non-terminal, equals new underscore state, then go to state, non-terminal equals new underscore state. 4. Parse the input asterisk. Asterisk initialize the stack with the initial state, state 0. Asterisk repeat until accept or error. Asterisk look at the top of the stack, the current state, and the current input symbol. Asterisk consult the action table. Asterisk shift asterisk push the input symbol and the new state onto the stack. Advance the input pointer. Asterisk reduce asterisk pop symbols from the stack according to the right-hand side of the production rule. Push the non-terminal symbol and the new state, obtained from the go-to table, onto the stack. Asterisk accept asterisk parsing is complete. Asterisk error asterisk syntax error. A code example, Python. Let's take a simple grammar for arithmetic expressions. Here's the Python code to construct the LR0 automaton and parsing table. I'll explain it in Telugu-friendly terms as we go. Explanation in Telugu style asterisk. Asterisk LR0 item class asterisk. This is like defining a small unit in our grammar. Imagine a laddu. This class represents a laddu with a dot indicating how much of it you've eaten, parsed. Asterisk closure, items, grammar, function asterisk. This is like expanding your knowledge about a topic. If you have some initial information, the items, this function adds all the related information from the grammar, until you have a complete understanding. Asterisk go to, items, symbol, grammar, function asterisk. This function tells us where to go next based on the current state and the input symbol. Like following a road sign to the next destination. Asterisk build underscore LR0 underscore automaton, grammar, function asterisk. This builds the entire state machine that the parser uses. It's like creating a roadmap of all possible states and transitions in the grammar. Asterisk build underscore parsing underscore table, states, transitions, augmented underscore grammar, function asterisk. This creates the action and go-to tables, which are the decision-making tools for the parser. Like a cheat sheet that tells you what to do in each situation. Asterisk find underscore production underscore number, production, grammar, asterisk. This function helps locate where the grammar rule number is and is used for reduce actions in the parser. Asterisk parse underscore input, input underscore string, action underscore table, go to underscore table, grammar, states, function asterisk. This is the main parsing loop. It reads the input code, uses the action and go to tables to decide what to do, and ultimately either accepts the input, if it's grammatically correct, or reports an error. Important considerations and LR0 conflicts, value. The biggest limitation of LR0 parsing is its inability to handle conflicts. There are two main types. Asterisk shift reduce conflict, marputhagan chuvaraum. In a given state and for a given input symbol, the parser doesn't know whether to shift, move the symbol onto the stack, or reduce, apply a production rule. Asterisk reduce conflict, thagan chuvaraum. In a given state and for a given input symbol, the parser doesn't know which of two, or more, production rules to reduce by. LR0 parsers cannot resolve these conflicts without looking ahead. This is why they are less powerful than LR1, SLR1, and LALR1 parsers, which use look-ahead symbols to resolve conflicts. How to handle conflicts, Telugu perspective. Imagine you're at a wedding buffet. There are two avakaya dishes that look very similar, but one is slightly spicier. If you can't taste them beforehand, no look ahead, you might pick the wrong one. This is like a reduce conflict. LR0 still matters asterisk. Even though LR0 is limited, it's a good starting point for understanding parsing concepts. It's also used in situations where the grammar is simple enough to avoid conflicts. Learning LR0 is like learning the basic alphabet before you learn to write complex sentences. Summary, Son Graham. Asterisk compilers translate code from one language to another. Asterisk parsing is a key part of compilation, ensuring the code structure is correct. Asterisk LR0 is a bottom-up parsing technique that reads input from left to right and derives from the rightmost side. Asterisk it uses LR0 items, states, go-to functions, and action tables to parse the input. Asterisk LR0 has limitations due to its inability to handle conflicts without look ahead. I hope this Telugu flavored explanation is helpful. Remember, Understanding parsing is a key step in mastering compiler design. Practice with more examples, and you'll become a parsing expert. Let me know if you have any other questions.